Hi, it's Gadget UK here again, back for part 2 of the AGA Multifix. Thank you to all the people on Patreon and my Discord that got together and bought me this for my birthday. So hopefully you saw part 1 where we built this and dealt with the initial issues, got it actually working, but there was a problem with scan lines, you know, the interleaving in interlaced mode, and there's some more problems in this video, as you'll see. I've just spent quite a while speaking to Sparks UK about this. Thanks ever so much for your help, Barry. And I've looked at this previously off camera, trying to connect our, you know, AGA Multifix here to the RTG card. So this will be a separate video. Again, this has come from the amazing Sparks UK. So I think what we need to do is disconnect that from there, yeah, and then remove the jumpers from here, and then it's just a question of which way round does this go? I don't know. And it's going to go on there like that. But you see, this is a pass through. In other words, if these jumpers are not fitted here, you don't get any video out there. So this is where I get confused, because if we remove those, the video doesn't go here. It comes across here, but does it come across and then back out? Because if it does, then that would just work by just plugging that on there. So anyway, I'll report back in a minute. And herein lies the next problem. Look, I can't get the card into a slot, so I need a huge cable for that, I think. I'm just going to check, make sure I am doing this right, but I don't know, it just feels like this is not destined to work. You can see the desktop looks fantastic. You can still see the lines down here, the striations, which I think are from the video cable. But we'll revisit that towards the back end of this video when another cable arrives, just to see if there's any difference. It might be worse, I don't know. Trying to find a decent quality cable is quite hard. There's a bit of sparkling there, don't you? Can see it on the top of the S. It's like on the D, little blue pixels. Yeah, so all this looks okay, and it appears to be in just like high-res mode. But can you see all the little yellow dots around there for the highlights of the lighting? Let me zoom you in a bit. Yeah, you can just see this flickering here. Hang on. Yeah, and here, there's little pixels sort of flickering in and out. And on there, it's not as noticeable, but it is around the blue bits. Just wait for the main title screen to come back up. Yeah, hopefully you can see the flickering around the frog and on his nose. And again up here. Right, so here we are in the game. The grass line, there's some little flickers going on, and on the silhouette, you know, the background there, the trees. Let me zoom in, and hopefully that's going to get captured. There's like little sparkles on the edges of the trees and on the grass. I'm not sure if you can see, just the odd pixel flickering in and out. So in general, it's very good, but in some ways I kind of prefer the HDMI upscaler, because you don't get any of the sparkly stuff going on. You don't get the scan lines being, you know, interleaved there in an interlaced mode, you know, like the offset by a pixel or something. But that does give you quite a natural blurriness if you're using a CRT for your VGA output. Because you're using an LCD here, obviously, it's still a bit blurry. It's like a natural aliasing, but you know, it really kind of stands out and slaps you in the face to a degree. I'm just trying a bit of Bart versus the Space Mutants, I think. Yeah, so it looks pretty good actually. Really nice, crystal clear. And I managed to get that switch working on the back for the black level. You'll see if I switch it back off the other way, see how it went brighter. Yeah, so the reason that wasn't working with the firmware that I'm using is there's a jumper there for the blanking, whether it's, I don't know, it triggers on the negative edge or positive edge, and I just flipped that over, and then that black level switch started working. So I'm very pleased with that actually. It means that this card is, you know, 100% functional. It's just the glitch as you saw on Super Frog there. Yeah, so like there's no sparkles and things going on there. Yeah, and starting the game there, you can see it looks absolutely amazing. We've still got these lines, but as I said, that's the cable. I don't see any speckles or anything going on there. Oh, hang on, there is. There's a little bit of speckle in there. Let me zoom you in. Yeah, can you see these pixels here? Kind of like dancing around a little bit. And on the Sony LCD TV here, straight from the RGB signal, there's none of that flickering going on. So it's a bit of a mystery to me as to what's the cause of that. back on the VGA screen, you can see it's there. Yeah, a bit hybris there. We've got exactly the same thing, some sparkliness going on. Yeah, just look at the edge here. It's like little blue pixels flickering. So it's strange, it seems to be just like where you've got like bright blues or yellows, I don't know. So I want to show you a few things here. The first thing is the hood here is not connected to ground. This isn't connected to ground. Yeah? They're not joined to each other. We've got a ground, is it there? I think it goes ground, doesn't it? Hang on, let's just confirm that. Yeah, analog ground is the left-hand jumper there, so the first pin there is ground on the regulator. That's not grounded. That's not grounded. The headphone jack is, yeah? So the grounds on those, certainly that, should be joined to ground. So I'm going to have a wire from there to that on the underside to ground those. This may explain the lines down the screen, because you know what? The shield is probably picking up its ground from here, and if that's not shielded properly, you're going to get lines down the screen, so that might solve that. But the sparkles, I was about to test with some copper tape on some of these long traces, actually, on both sides, because that might be the sparkle. Like when you've got the highest intensity of one colour bit, it's causing some parasitic capacitance somewhere, some inductive coupling between traces, because there's no ground plane in between lots of these things. There's obviously, and the ground isn't even joined up down here, is it? So yeah, I mean, the problems may go away as a result of joining whatever rail this is here, you know, the can thing here, these big things, because that's not grounded. That's going to cause a problem. So just by virtue of having a, let's say, from the ground of this to that might solve it anyway. But I'm just going to leave that copper tape there, and then the next thing is I'll join a wire from there to the common ground over here. Anyway, I'll report back in a minute. So I just joined the shield of the USB to the shield of the 15-pin high D-type connector, and then from here to the audio ground. So yeah, all the grounds are joined. Now the interesting thing with these black lines is they're more pronounced after grounding that, which makes me think that those lines are actually created by this board, and maybe a piece of copper tape on the other side may help, actually. But anyway, yeah, that copper tape is grounded now, so I'm just going to retest, I'll report back. Yeah, that's massively better, but there are still some sparkles, and you know what? It's on different places slightly. I think this is the traces on the other side. So I think it needs some more copper tape, actually. Yeah, we've still got the jaggies there, so that's a firmware thing. Yeah, that's massively better, but there are still some sparkles, and you know what? It's on different places slightly. I think this is the traces on the other side. So the interesting thing here is if we swap over to one of the PAL chips, well, two of the PAL chips on one colour, the speckles seem to go away. Now, they're not completely gone away, but initially here they've gone. I see 0 of them. None on the blue here, none on the yellow. If I keep clicking to get the tile screen back up, you know, this circle around the frog, there's none. So that makes me think it is the RAM. Now, because there's 6 of these chips, yeah, the 6 of the longer ones, 6 of the shorter ones, I'll show you that in a minute. I swapped the longer ones in pairs. You know, you're going to have 2 for each colour. And it was only when I got to the top of the card that the problem was resolved. So that makes me think one of the 2 chips I've taken off are faulty. But it's not completely gone. As it warms up, you do just get the odd one. But it's strange how it would manifest in this circle. You know, it's like it's specific parts of the dithering. You know, there's Liv 2 pointed this out. The thing that it's got in common there is it's where you've got the dithering going on. You won't be able to see it from here, but this is where you get these it's like every other pixel is a different colour, and maybe that's causing some sort of glitch in the transitions. You know, it's going like high low, and then you get this certain pattern where maybe some parasitic capacitance or something, or a fault with the chip means that, I don't know, it's not switching properly. You know, it's not capturing that bit as it should be, as it's serializing. Because that's how it does it, I think. I'm pretty sure for each colour, you know, you've got RAM that, the data is serialised as it's clocked across, into the chip. It stores the whole scan line. So here's the chip that I removed. I'm holding the wrist strap here, by the way. Yeah, the ones that I've removed end 101. The one that's fitted is 102. So this is NTSC, and it has, I'll stick it up there, it's like a certain number of, you know, pixels, effectively. And the PAL, it's got a different amount up there. So all copper tape are removed, so I think I've proven we don't need any copper tape. I don't really see any flickering pixels at the moment. It's been on for a few minutes here now. So yeah, it would appear to be just RAM based. Anyway, I think what I'm going to do next is just put it through the ultrasonic cleaner and I'll test it for a period of time and report back. Lots of horrible smeary streaks and things. You can see I just wiped around here and there's a horrible pattern there. So yeah, I'll get it in the ultrasonic again. I'm sure I've done this, perhaps earlier in the video, but it's been sat around and knocking around for so long now without me finishing this video. So yeah, it's got a bit dirty, hasn't it? So at this point I was doing a lot of work with copper tape, swapping chips around, trying to work out exactly where the cause of the problem was. But I kid you not, I've spent hours and hours and hours and hours and hours and I've removed so much footage from this. So just testing the two of Tom Mead's chips here. I don't know, you can see we've got some like purple bars going down the side there. And if I get the title screen back up, hang on, it's not doing it now. This is really strange. Yeah, we had some like things going down. Oh, there you go, you can see them there. So yeah, I think some of Tom's RAM is bad. You can see it there. This blue stuff in the corner. What is strange is how it, you know, on this one here, it affects the outsides of the screen, and obviously on the orange here it looks fine, but bear in mind it's affecting a specific colour, probably the blue maybe. Yeah, anyway, so yeah, I'll need to swap out one of Tom's chips. I need to try and work out which of those are faulty. That's going to be obviously another video. Right, super confused now. I've only got half the chips on here. The bottom chip and each colour is installed. We've got the flickering back, yeah, and this is with chips that were on there that worked. You can see that there, you can see the flickering. So is there a timing issue with this card? What I don't understand is when I put the PAL chips in, we don't get this, just in that particular colour. So I don't know, is it specific to this game because of the way the colours are driven and that colour's been affected and you put PAL chips in and then the timing's slightly different, so then it's alright. I don't know. And you can see how I was testing that there. I've only got half the chips in. How is that even working? I'm guessing if I tested interlace mode, that's where the issue would be with these missing chips. I might just do that. We might get a scanline effect. It may just give garbage where the scanline, you know, is not held. I don't know. But these chips here were in other banks, if you think about it, you know, like I think those two came from up here or something. So the problem seems to be when this area here is filled with this type of chip. You put the PAL chips in this area here, problems go away, which I'm having a real hard time trying to understand, unless there's some timing thing related to this colour channel. Maybe it's trace layout related to this colour channel. Maybe it's this and it works better with the PAL chips than the NTSC ones. I don't know, it's really mysterious, this. Well, now I'm even more confused because it's only got half the amount of chips on there and interlace mode's working. We've still got the jaggedness, obviously, because that's a timing thing on the firmware, I think. The only thing I can think is the additional chips are only needed if you run this in a 4000 for the AGA stuff. That must be what it is. So if you're building one of these for 2000, you only need the bottom chips populate. Sorry, is it the top chips? I forget. It's just strange, isn't it, how that colour issue only seems to manifest on Super Frog at the moment. That's the thing I'm having a really hard time understanding. Let's just start this game, see what it looks like when it actually starts, because we haven't done that yet. See, like, that looks alright, aside from the jaggedness of the misalignment on the interlacing. Don't see any colour issues there. Right, I think I'm starting to finally understand this issue. Well, I've got some clues. It's the middle RAM again, you know, the middle, whatever colour channel those middle two chips are. If I swap one of those for Tom Mead's chips again, it works. Any of the chips off this card in that position give the glitch in. So there's not actually a fault with the RAM. I think this is pointing to board layout, actually. There must be some inductive coupling going on somewhere just around that colour channel. For whatever reason, when it's got the PAL chips on there, you don't get the issue. But with the NTSC ones, you do. I mean, it's night and day. It's like, I've just literally tried 4 different chips, you know, on there in that position. And every single one gave us the speckled circle in the middle. As soon as I change back to Tom's again, it goes away. So it has to be a board layout thing. Yeah, still getting nowhere. I've had to mute the crazy music. Yeah, I've removed the green. The middle chips are for the green. And I don't notice any flickering, but you know what? The thing is, green is the colour we're most sensitive to, our eyes. And obviously, you lose a lot of brightness here. But it looks pretty solid. And when it loads, the loading logo, there was little blue speckles appearing there from the green, I think, being increased. So, yeah, I'm not really sure what this reveals. We know it's a problem with the green channel. I think what I might do next is put the green back and remove one of the other channels and just see what happens. I'm looking for a relationship between the two channels, but also just to prove conclusively, is it just the green? I think the final test I'll end up doing here is just with green and nothing else, and see what we see. So I've swapped one of the chips into the green position, and it now looks like we've got green and I want to say blue, but I saw a blue pattern go up the screen there. So you know what, I'm thinking, oh hang on, we've got red. We must be missing blue. It must be red and green at the moment. So yeah, that would make sense. So the bottom chip nearest the edge connector is blue with green in the middle. And I just want to see what it looks like now, and then I think the next test is just green on its own. Yeah, zoomed you in a little bit here. Can you see here? These blue pixels? Those shouldn't be blue. So we've got the problem straight away with the green back. Yeah, look at that now. It's horrendous. Look how noticeable that is without the blue. Yeah, without the blue, that's right. Just red and green. So let's just test green on its own. Is that green enough for you? That's like pretty good, that. I quite like that green screen. It looks lighter green on the camcorder screen than it does to the eye here. It's a nice dark green. But of course it's the green that's the issue. Here we go, loading screen, let's see what... Yeah, look, we've got the flickering here now straight away. Just with the green on its own. The other colours can't even be interfering at that stage. I'm guessing it's going to be spectacular here. Look at that. There we go. Zoomed you in a little bit there. You can see how bad it is. It's highly noticeable with green on its own. But why? But what's wrong with green? This is the thing. It has to be a board layout thing. I don't see what else it could be. Super noticeable here. Right, I tried a bunch of different chips in that position there, and they're all doing that, so it's not the chips. There's nothing wrong with any of the chips. I think it's just a red herring. I confused myself, because if I put a PAL one in, we don't get this issue. Only in the green position. Oh, God. Can you tell I'm getting cheesed off yet? Look how bad it is now. This is from adding copper tape. Yeah, around the green. I think the green is a red herring. I actually don't think it's the green. I think the green is being affected by something else. Adding the copper tape on seems to have exacerbated the problem. Maybe it's the blue? I don't know. I'm losing the will to live working on this, seriously. What I really should do, you know, if you're an intelligent person, and I'm not so much, some days I am, is get a logic analyzer, get some test patterns of certain colours and certain, you know, I don't know, arrangements on the screen there. You want something where you can stimulate the problem and then do a capture based on a consistent set of data, like not some scrolling, you know, random pictures changing like this, because then it'll be really clear when one bit is flipping state. And I think that's what's happening. I think it's like the uppermost green bit is being affected by one of the blue bits, and adding the copper tape has solved, well, I don't know, it's kind of added to the problem, hasn't it? So the blue is now able to influence it even more because the blue doesn't have any copper tape. I think that's what's happening. I'm going to just experiment putting some stuff around the blue, but yeah, it's proven very difficult to work out this. Yeah, the copper tape is making this worse, you know, it's like almost a solid ring now. That makes me wonder, actually, if some pull-down resistors are needed. So I think I've worked it out, and it's taken me days to get to this conclusion. God knows how much I've done. The last thing I did was testing with pull-ups or pull-downs. I went through pull-downs first, then I tried pull-ups. On the data inputs and data outputs to each of those RAMs, it made zero difference, none that I could see anyway. So yeah, I've done a temporary fix to this. It'll be a separate repair video, because this video's gone on long enough as it is. But I think it's a fault on this 2000. Now, I've obviously been swapping between the Rev 4 and this board, the Rev 6, numerous times there, trying to rule out certainly the issue with the scan lines on the Interlaced mode. But I thought I'd tested this on the other board the same way with the Speckle pixels. I honestly can't remember now. I don't think I did. I could be proven wrong. We might be back in a minute or two where I prove actually there is still a fault. But at the moment, there is a fix. Like I said, temporary fix here. It's still going to glitch just a tiny bit. Yeah, so I can see just the odd speckle. You probably can't see anything from there. Right, but just watch. I'm just going to do something that undoes my fix. Hang on a minute. Let's get the frog back up. You ready? 3, 2, 1. You notice the ring there? Appears straight away. Yeah. So, yeah, anyway, I think that's the issue. So I'm going to now fix that. So the fault at this stage, I think, is this chip. Now this is the board that had a previous repair related to the DAC. This resistor had burnt up, and this is what feeds the supply to these. So you know what, that could just be an after effect to the original fault. You know, if this chip failed one of the inputs, this could have then shorted, and then this is still working, but it's glitching. It's doing something with one of the bits there. I can scope it after the event. We'll socket this up, but the way I was testing there, you'll notice it was you know, there was no issue. I had a chip piggybacked on top. Now I've only got an F244 at the moment. This is a HCT. I've ordered some HCT chips, and obviously that level difference could make a difference, although this is I think this is just buffering the digital actually, so it should be alright. But in theory, you know, you could cause some sort of problem with your RGB output as a result of changing that for the wrong type of chip. So yeah, anyway, we're going to get that chip off and see if that fixes the problem with an F, just temporarily. You can see my VSync mod here. That's definitely, absolutely, 100% got nothing to do with this issue. So yeah, it's this chip here, the one on the inside. So I'm just going to add a wee bit of fresh solder to each point here, and then just going to use the desolder pump and just quickly get this off. But I'll be very pleased if this fixes it, because I kid you not, I've spent about 3 days or more experimenting with this, trying to understand the nature of the problem. It's strange, isn't it, how the copper tape made it noticeably worse, which, when you get that kind of thing, you start thinking high impedance. Yeah, because if something goes high impedance and you've got copper tape near it, you are more likely to pull that signal low. And that was why I then went around with a logic probe. Activity on all the pins, obviously. So there was no floating connections here. But I think what's happening is, you know, this device is tri-state, isn't it? You can have highs and lows pass through, and you can have high impedance. And I suspect that when it goes high impedance, it isn't high impedance. It's actually outputting a bit or something. So most of the solder's been freed up there. Let's just pivot on these. I'm just going to free it with hot air. I don't know if you can see, we've still got some bits of solder around there. Doing it this way is low risk if you preheat and you don't go too high. So perhaps a wee bit close there, but I'm just going to get the extractor onto the chip in advance and then use the hot air around the 400 degrees mark and just heat the underside here as I gradually pull. We'll just heat up the wider area first though. Yeah, I can smell that heating up, so hopefully it'll come off in a minute. Yeah, it's starting to come through. It's off. And there we go, from the top side you can see no damage, not even any discoloration from the heat there, so yeah, I just need to unblock the holes, get a socket on, and then we can try it again. So often I'll just use the desolder pump, but I'm just adding a tiny bit of flux there. I've unblocked most of those there with a braid. All we're doing is deforming the surface of the solder here, more than anything. Just helps the socket go on a lot easier. That's not too bad, I don't think. 10 pins on each side of these chips. Struggling a bit this top corner here. Yeah, that's in place, so flip it over, solder it on. So place your bets. Do you think this is going to work or not? I'm kind of mixed feelings here. I think it may work with the other chip, but there might not actually be a fault here. The thing I'm having a hard time understanding, you see, is the RGB. When you get those speckles around the screen, the normal RGB on the TV looks perfect. No flickering, no speckles. That's the bit I don't quite get. But you see, that could be because the hybrid is quite happy with the logic levels, but the Scandoubler ain't. Right, so just plugging the mouse in, let's see what happens. The colours look alright on there. On the TV, they look weird, I'll show you in a minute. It's obviously because of the logic level. There's a logic level difference, but in terms of here, we shouldn't notice that problem. So if we go into Super Frog, what is amazing is when I tested those 244s, I picked the right one right. Well, it's 50-50, isn't it? But that's the one I piggybacked first of all. So let's see what happens now. Now, obviously, it does take generally about 4 or 5 minutes before the problem just suddenly appears. Yeah, I'm calling it fixed actually. Yeah, no issue so far. So yeah, I'll get that nice and warm, test it for 10-20 minutes, and I'll report back. And just showing you the brightness issue there, can you see? It looks pretty dark, that. The green isn't as strong as it needs to be, and probably one of the other colours as well, or some of the bits of the other colours, because they've got 2 of these buffer chips there that buffer the red, green and blue signals. Yeah, so it's pretty dark compared to the output from the Scandoubler there. And the reason being is, like I said, because HCT is, I think it's CMOS compatible, but it's a HC chip, isn't it? So internally it's CMOS, but it's TTL compatible. This F is going to have a slightly different level. It may well be that whilst it's TTL compatible, the HCT, it's CMOS in terms of its outputs. And I think that's probably more likely actually, because I think that's why it looks dark. So anyway, I do need source HCT 244. A good 30 minutes, no issues at all, so yeah, the problem is definitely resolved. It's hard to believe that this little frog has given me such a hard time, because you know what, everything else I tested looked alright. It was just this game, which is weird, isn't it? And it's going to be to do with the you know, the bit patterns there. And it started on the tree line there. You know, that's where I first showed you the issue. I'm kicking myself that I didn't retest on the, oh, I walked right into that, didn't I? Yeah, on the Rev 4, because I'm not sure if you can kill those. Yeah, you can. Yeah, I should have tested on the Rev 4 again, but I felt like I was going around in circles to a degree because I tested some of the other things with the Rev 4, and I thought I'd actually tested that specific issue, but clearly not. So anyway, I'm pleased it's resolved. Yeah, so I need to remove all that horrible copper tape now, don't I? And clean it up yet again. So yeah, the copper tape helped me work out that there was an issue, because when the copper tape was not there, it was really minor, and it would take forever to get fairly noticeable. With the copper tape in place, it was instantly, you know, more or less after 30 seconds of power on, a full circle around the frog. So yeah, that was the clue. And the reason being is because those RGB inputs into these chips here, you know, the green is in the middle here. This is where I was focused on, which is why most of the traces are around the green stuff here. As soon as you copper taped around the green, bang, sphere right around the frog. I looked at I think the inputs, it's these pins here, actually, inputs and outputs, 4 pins on each side, all looked okay. But one of those is obviously the one that's affected, that is coming from that 244 on the motherboard. I'm going to scope it next, actually. We'll clean this up, and then I'm going to scope the old chip versus the new chip. So I found some HCT 244s I didn't know I had, so let's fit one of those. Yeah, I'll show you sort of a before and after on that same game. It's always annoying when that happens after I've ordered some of the chips, so let's use the dip extractor. And press it in. So let's see what that looks like. It's an ST part, this one. The one we removed was Philips, and you know what? Some of those Philips chips are notorious on arcade boards. You might be able to see the difference. I'm not sure if I showed the desktop before there, but it's much more equal in colours now. It doesn't look dark like it did. Yeah, I was casting my mind back. I think I got these HCTs for a Neo Geo. Yeah, that's much brighter. I'll put a before and after. Here you can see how it looked, and now how it looks. It is brighter. And super annoying frog. Yeah, that is much brighter. So this is as it looks now, and this is how it looked before. So one final point on why was the RGB dark when I was using the 74F244, and I think there's going to be a difference in logic levels on its output versus a HCT 244. And you may think, just looking at the schematics here, you know, you can see red, green, blue goes into the hybrid, but it's digital, it's high or low, and you're asking yourself, how could that make a difference? And I think it's all about a resistor ladder or something like that used in the DAC perhaps. So in other words, the logic level of those high signals when a colour bit is set can dictate on how bright it actually translates into, I think. Because you know what, I double checked and I'm darn sure it was dark with the 74F244. So I was about to clean up, but then I thought, well, let's just swap this one anyway. And now I did see a blue speckle somewhere else, actually, on the blue circles or whatever they are on the Super Frog. Just 1 or 2 on the side, so I thought, well, you never know, in for a penny from for a pen, let's swap them both. There we go, that's looking pretty darn clean. These traces here are just melted or something. It's obviously been damaged in the past. Yeah, so looking perfect now, but there is still an issue with this card in general, I think, in terms of trace layout. Because once it warms up, can you see here, on that green circle? Yeah, you do get tiny bit of jitter or something from 1 pixel changing state there under certain circumstances. I suspect if I put the copper tape back on that would go away, but that's with brand new HCT 244s, and in general the picture is a million times better. If I change back to those other ones, the problem will come back. So out of interest, I put the faulty chips back in, swap them around. I don't know, you can see we've got a purple band straight away down the side there. Yeah, you zoomed in pretty close. I'm not sure it's going to get lost in compression, but there's purple on the sides of the blacks there. Anyway, let's start that same game. I am curious to see how it behaves. Strangely enough, it's the same blooming bits, even though the chips are in a different order here. I mean, I'll double check that, but I don't know, I don't understand that. It makes me think there's nothing wrong with those chips, and it's... Yeah, look, we've got the same pattern. That is really, really weird. What is it with those chips that's the issue? And for whatever reason, the manufacturer, the ST ones, they just play ball better, even though it's a HCT part just the same. So I would suggest if you've built one of these, you're getting some glitching like I'm getting here, weird colour things, swap them out for some ST ones. I mean, I'm guessing it's going to be exactly the same. Yeah, it is. It's got the dots, you can't see them from distance, dots on the top of the D, I and S. And then I'm guessing we're going to get the same orange ring around super annoying frog. Yeah, there we go. Isn't that crazy? I mean, technically they could both have exactly the same fault. Like, it's not a bit that's faulty on them, they got overvoltaged or something at some point, and I don't know, both of them are behaving the same sort of way, but I don't know, that's really, really strange. And if I swap back for the other ones, it'll be good as new again. Yeah, and I've swapped back for the ST ones, and it's perfect. There's no purple ghosting or anything. So, I don't know, very, very, very odd. The other thing is, and I'll show you these two chips in a minute, they are different. They're not the same. They're both Philips, but they look like being manufactured in a different place. You know, they've got slightly different part number. And they both, you know, cause the same problem, no matter which order round they're in. And RGB is crystal clear perfect. So I don't think there's anything wrong with them at all. I think all that's happening here is we've worked out that the RAM on the card is a wee bit picky about what HCT chips you've got. Yeah, this is useful information. I guess anybody out there's got the Philips chips, you want to swap them out because you're probably going to get these little glitches and things that may come in over a few minutes, or like this there was here, but yeah, everything's gone back to normal now. So I do hope Super Frog has annoyed you as much as he's annoyed me. I'm sick of seeing that screen. But can you see? Yeah, they're both Philips. Subtly different part number. One ends with a P, one ends with an N. One starts with PC. Yeah, and you can see I marked them. And I've tried them both ways round to get exactly the same graphical behaviour. And just for completeness here, I bought some brand new Philips PC74HCT244s, tested them out, same problem as the original ones I removed. And I removed the second set from my Rev 4, same problem, exactly the same issue. So what's different about these Philips chips? I don't know. Liv2 mentioned, is it about slew rate? I don't know. What I do know is the ST parts upon, which I think are genuinely, do look genuine, they solve the problem. So what is the difference between an ST74HC244 and these Philips 74HC244s? Now I think Sparks UK tested his 2000. I'm not sure whether he tested the same way, whether he used his ATX 2000, I'm not sure. And I'm not sure which revision chips he had, but he didn't have the problem. He couldn't see the problem with Super Frog. But as I sort of explained, it takes about 10-15 minutes. And I found that if you put any of these chips on there, you can speed up the process, just get some hot air, 100 degrees, within about 10 seconds, a ring forms right around the frog instantly. So the the issue, this impedance issue, that's what it is, temperature sensitive. So really strange. If you know more, if you've got any ideas, post in the comments down below. So just testing those two chips on the Mini Pro. Sorry about wobble cam, but as you can see, they're testing okay. So adding this bit at the end here, I scoped the old chips versus the ST chips. I couldn't see a difference at all. They look exactly the same, so I don't know. So just using Tom's card to test my NTSC RAM out here. Got a supply of it, just in case I want to make another one of these, and also for an upcoming project. You'll see that. Yeah, I'm not 100% convinced on the results of this. I've got a ground and VCC, ground down here, VCC up here. It's a faulty Agnus, this. It's one we discovered in a recent 500 video. It's like part 7 or part 8, I think. Yeah, it's drawing about 200, just over 200 milliamps, so there is a fault with this. But from what I could see, it was just the clock gen stuff. I think it was outputting video, you know, it was giving CSYNC and stuff there. But if I use the scope, it's like the 6 pin up on this side, I think here, which is the CSYNC, and I use this logic pulsar here that came from Anthony over at RRG. You know, it puts out pulsars there, seemingly low ones, which is what we need. So we've not got proper video going out of this at the moment, but nevertheless I'm just testing to see what happens when we influence the VSync. So if I go 1, 2, 3. Right, so that is the CSYNC. You can see at the moment it's sat around 2.8 volts. Bear in mind it's faulty, but there isn't a fault with the, like I said, the CSYNC and H-Sync, VSync stuff. So if we stimulate the H-Sync, you can see it go down. This is just putting pulses into the, and it's not showing the chip out. If I watch the current on the power supply, I'm just going to do that in a sec. Yeah, it's not shorting out the supply rails here. So we're getting those low pulses, and I have to keep tapping it because of the impedance here. You can't just hold it in place with this because it's not classed as an input. But nevertheless, it makes the C-Sync go low. And the same sort of thing happens to a lesser degree with the V-Sync on this chip. You're not going to be able to see it, but as I actually tap, oh there you go, it bounces up and down a bit. So I think my theory there is perhaps right, that some noise is getting into the C-Sync, you know, reflection or something is backfeeding at the point where the Agnus is merging the H and V-Sync. I think that's perhaps the issue. I mean, someone else would need to confirm that, I think, but because I'm testing on a dodgy chip here, but I think that that's what's happening. So as you can see, I've got a new video cable here. It's much thicker, better than the cheap $1.99 job or something I was using previously. And this does give a better picture. But it isn't just about the cable. You know, the lines I mentioned in part 1. It isn't just about the cable. It's also about the display. If I bring the menu up, I know I've got a black screen while it's booting here. And if I go up and down these menu options, can you see here? Clock and phase. I adjusted these and the lines basically disappeared completely with a combination of that new cable grounding the 3 connections, yeah, because they weren't joined, you know, the ground on the video connector and the USB were not joined to the headphone ground. Once I did those things with the new cable and made some adjustments here, the lines went completely. Right, some new RAM has arrived, so I just want to remind myself of the interlacing issue with Alien Breeding of the games, and then I'm going to swap half of the RAM with some PAL RAM. And I think I can do that on this card, because I think half of the reason there's lots of chips, they've been quite cleverly split, and I think half of them are used for like this standard mode, you know, non-interlaced, and then the other 3 chips are used for interlaced. And if I can swap the 3 that pick up the interlaced frames, I suspect I might just be able to fix it by having a mixture of PAL and NTSC RAM on the same card without a firmware update. But bear in mind, there may be a future firmware update to solve that. Right, so here we are. Yeah, I can see the jaggedness straight away there, I think. Yeah, and on here, super jagged. Yeah, there we go. So we can see the jaggies there. I'll now swap 3 of the NTSC chips for PAL chips and show you what that looks like. So half PAL line RAM and half NTSC line RAM. That seems okay. Now I'm not sure whether I've got the right 3 chips, and I'm not sure whether 3 chips is going to be the thing here, because the thing you've got to remember is when I was looking at Tom Meads' card, the red, green, blue signals, you know, for the different modes and things there were going through different pins on different chips. It's like one single chip was not responsible for one colour. But I think on here they've kind of done it logically. So this may work, but I may have the wrong 3. I might need to just swap all 6 chips around, you know, the pairs. Now that's looking straight now. I think that's fixed it. No, it hasn't. Yeah, still got the jaggies here. So I must have them the wrong way around. And of course, I could be wrong here. This might not fix it. but I suspect it will, because I think once the interlaced frame, I think is going through a different chip. But it might not be doing. I might need actually 6 of these PAL chips. Yeah, so we do still have the jaggies. So I've got the wrist strap on. We just need to swap the pairs. So like that one, we're swapping that one for that one, that one for that one. Because then we've got PAL, NTSC, PAL, NTSC, PAL, NTSC. Right, well this is interesting. Now I've swapped those pairs around, you can actually see there's a huge difference in alignment. So you know what, that hasn't solved it, has it? Let's just try and switch the switches on the back. Yeah, so that one puts it out of range. The other one, yeah, that's just the black. So what I do know is that when I had PAL chips in here earlier, that problem was solved, but I think that might be with a previous firmware. So I think what I probably need is 6 PAL chips on here. But then again, if I had 6 PAL chips, you can see the A starting all the way over here. The alignment's well out, isn't it? So that would suggest that you really need NTSC chips with this firmware. Let me just try changing the sync from whatever it is to the other, you know, like from negative to positive or whatever. Yeah, strangely enough, no video at all when it's set the other way on my setup here. So, I don't know, it does seem to be just the RAM in general. If you swap all the RAM for PAL RAM, the Interlace issue solves itself. But with NTSC RAM, it's like 1 pixel out on the Interlace stuff. So just testing on the A4000, hence the wind tunnel noise from the fan. I will get like a Noctura fan in there at some point. So yeah, AGA now. Looks fantastic. Crystal clear. Yeah, there's just a tiny flicker at the top. We saw that I think when I first tested this on the Philips LCD TV, but it's hardly noticeable actually. And we've got Live2's Zorro 3 RAM board, hence why we've got 345 megabytes of RAM, and the TF4060 Proto, which all coexists nicely. Oh, it's a dream machine, this, it really is. Let's just try an 060 demo. I assume that these 060 demos do use the AGA modes. I think I may have switched one of the switches into the wrong position. Let's just try them. Hang on. Yeah, it's not that one. That's interesting. The one that gives the darker black makes it look like that in AGA. So, isn't that strange? Anyway, it looks absolutely brilliant. Wow. That's crystal clear. It really is. Let's just try Alien Breed on here actually. I mean the black level thing is different already. You know, that switch is no longer working, which is strange. Yeah, it's crystal clear here. We don't have any issue at all. So, for whatever reason, this card seems better in the 4000 than the 2000. Makes me think about clocks again actually. Maybe one of the clocks is not as clean as it should be in the 2000 there. This is now perfect. Absolutely perfect. I mean, granted, the name of the card, AGA Multifix, is designed for the AGA systems. So I switched the blanking jumper over from negative to positive, or vice versa, I forget which way, but I flipped it from where it was in the 2000. The display immediately looks okay there. I'm just going to just try that blanking level switch again, the one that gives the blacker than blacks thing. Hang on. Yeah, it's still not right, look. We've got some sort of offset going on. So that switch works on the 2000, not on the 4000. It's really weird, isn't it? How would it be system specific? I think I've probably got the WHD load switches set right, so maybe it'll work. Yeah, so the only disappointing thing I think with this at the moment in general is we've got two issues. We've got that scan learn issue of the 2000. I might go back to that, cover that within this video, see if we can work out what signal might be causing it on the 2000. But also the blacker, you know, the darker blacks switch doesn't work in AGA. It's still very impressive though, and crystal clear. Let's just hit fire. Let's just start that. Look at that. Fantastic. Wow. I'm going to leave this card in here, I think, ultimately. I'm so bad at this game. Well, you'll know I'm bad at most of these games, really. Yeah, zoomed in shot there, just so you can see how crystal clear it is. So, Pinball Illusions AGA, that's working fine, isn't it? Yeah, this does need AGA, you can't play this on OCS or ECS. Yeah, I always found this bit super mesmerising. I can stare at this for hours. The team, or some of the developers that worked on this, went to form DICE, didn't they? So things like Battlefield, some of the same guys, some Swedish guys, I think. Yeah, Digital Illusions turned into DICE, I think. Or is one of the same company. And a new piece of homebrew that you can buy. Highly recommended. I purchased this as soon as I was aware it was out for release. And there's been a few updates. I think it's on 3.6, is it now? Or 3.5, I forget. There might even be a newer one. Yeah, from Giza Games, the same guy who created the new version of Rygar, the AGA version of Rygar. And a few other games he's done as well. It's fantastic, this. It really is. Let's turn the sound up a little bit. So obviously it's not AGA this will work on OCS and ECS. I just want to see what it looks like, really. I've been playing it a fair bit on the over there with the 1084S, and it looks incredible on the CRT. But you know what? It don't look bad on this LCD here either. Oh, look at that. Fantastic. Yeah, you should be taking shots or something every time I say fantastic. I've said fantastic about 100 times in this video. What a brilliant birthday present. So yeah, if you haven't worked it out, it's a spiritual successor to Kung Fu Master. How cool. Oh, I hate leggers. What a leg. Yeah, take a few kicks, those gun guys. Real life, that'll come in handy. I think it supports two buttons as well. Like if I had the second fire button there, I could probably use that knife, I think. I really need to get well, I could actually, I've got the Master System controller nearby, I could use that. So we've got boss, first boss. It's quite a lot of levels as well, like 8 or 9, maybe 10 levels, I don't know, it's quite a few. Ugh. There we go. And there are some bonus rounds in between certain stages as well. Yeah, highly recommended. I mean, look at the detail, look at these posters on the wall here for 80s movies. It's just incredible, the love that has gone into this game. And you do get, obviously, different types of enemies on the different levels as well. It mixes it up quite a bit. So you've got one of those tall guys there, you've got to jump kick those to take them straight out. You can just kick and punch them normally, but they just take a lot more damage. And I'm guessing if you have the second fire button now, we would have a punch and kick. I think that's how the fire buttons work. You know what, I'm just going to try that in a minute, actually. I'm just going to connect up the Master System pads. Give me a sec. Right, I'm doing this while it's on. And I don't think there's a problem with the Master System pad here, it shouldn't kill it. Right, let's try this, see if we've got... Well, see if it works, yeah it does. Yeah, look, punch and kick. Oh, the buttons need cleaning on this, the punch button's barely working. Oh, that's really cool. Oh, can't waggle quick enough on the D-pad. Yeah, like Kung Fu Master, when you get grabbed, you've got to sort of go left, right, as quick as you can. Yeah, the punch button definitely needs some work. It's working right now. Oh, and it's not. Why is it not working? Yeah, I think it just needs cleaning, or you can't punch very quick unless you've had a power-up or something, I don't know. Anyway, that is really cool. Now there's a game I've not played in a while. I like to play that on my 1200 really, Star Trek 25th Anniversary AGA. It's a really good point-and-click adventure. You know, if you like things like, I don't know, Monkey Island, Indiana Jones and the Fate of Atlantis, Day of the Tentacle, this is a good game for you. It's AGA only. I'm not sure if it's going to glitch out or crash, just because of how I might have the switcher set for this game, but let's just say, I think that's working. Of course, the best version of this is actually probably the DOS version. So cool, that intro. Let's just hit fire, see if we can start it. Might need the keyboard connected. No, I managed to skip it without by pressing the mouse button. Yeah, very cool. So yeah, that's another AGA game. Everything's working fine, colours and nice and sharp, perfect. Yeah, so that's working fine, pixel perfect, crystal clear colours. So you start off in a battle simulation here where you're attacked, look. I honestly can't remember how you do this. You may even need to use the joystick, no? Or the keyboard, I don't know. So, do we really need a backplate there? Probably not. That USB port kind of gets a little bit obscured there, look, by the edge. One thought I did have, and I had a go at this, I've not given up yet, is getting one of these mesh ones and cutting it out, you know, maybe Dremel it. So I measured up to size, and yeah, I'm sort of on the way here. This obviously needs widening and flattening down and stuff. The hardest bit is down here, because it's almost the width of the whole thing. You need like literally a tiny sliver on each side to cover that. I mean, technically you could just finish up here, but then I don't know, I don't see what the point is. So maybe there's no point in putting that on there at all. You know, there's so few gaps between these things, maybe it's not really an issue. I'm going to have a bit of a clean in here in a minute, just to take the cards out, have a bit of a vacuum, because it's a bit dusty actually. But you can see it fits nicely into the slot there, and if I just now pull it out. Hang on a sec. Carefully, slowly, one way or the other. You can see the extra bit here, yeah, the extra colour bits connector on the end that relates just to AGA, yeah, and this slot obviously is slightly, you know, marginally bigger than it is on the 2000. And that's all that's for there, is the additional colour bits that AGA provides. Yeah, I need to be careful I don't damage the wires here. There'll be a link to the repair this, top right. It was the one from Stephen Leary, Terrible Fire. Amazing. Yeah, but I'm just going to have a vacuum around here, and obviously vacuums generate static electricity, so be very careful. I'm going to wear the wrist strap as well, but one thing you could use a tube. And you can see there how they connect. I think it's 10 pins this. Yeah, so pin 1 at the top there to pin 1 at the top here. We removed all the jumpers that passed the video connections through. So the video connections are going out and then back. Yeah, and it's merging the video there. And that's why when you use the RTG like this is why it's a bit blurry, actually. It's because of the impedance from the output from here. So when this is not outputting video, yeah, it's kind of like higher impedance than it would be if it was driving the signals. And likewise, it's the same when the video cuts out here when it goes into RTG mode. You know, you've got higher impedance. There will be some output there. It's not like it's just completely floating. Although, well, I don't know actually. I think you'll find when you watch the video for this RTG, you get same sort of thing, a clearer RGB, you know, VGA output from this direct, rather than when the two are sort of linked together. And obviously this cable is a factor as well. It's not shielded, it's a ribbon cable. There could be a better cable for this, you know, individually shielded wires here for the red, green, blue, H and V, and then instead of a flat ribbon cable like this, just have a normal one with a shield round and everything. But you've got to get the length quite long. You can see how to go quite long here, and this is just long enough. I'll stick the length at top left there. Anyway, that will be another video, but that is a beauty. I love that RTG. So, a bit of Menace here. I mean, it's absolutely solid, all these blues and things here, you know, that will show up like flickery and speckly if you've got any, you know, video problems like poor quality video output or video cable. But yeah, it's just crystal clear, absolutely crystal clear. Hopefully my joystick's going to work here. A minute ago it wasn't doing, and then up wasn't working. I think it might actually be the cable on the joystick. Yeah, so you do see the odd flicker, but I think that's just as it sort of does, you know, well, it flickers on the RGB is the point. It looks brilliant. It looks amazing. Yeah, my up direction's not working. I need to change the connector on the stick. That is annoying, because there was nothing wrong with that joystick a week ago. I'm not sure if you can shoot those. Yeah, you can. Wow, they take a lot of shots. It looks amazing. It's like, I almost feel like I'm playing this on an emulator. It looks so clear. Do you know what I mean? It kind of reminds me if I was to play this on the PC now in WinUAE, it would look just like this. Wow, that looks incredible. You know what this reminds me of here, this flickering? The MSX2 VDP. The thing I'm not used to here compared to RGB is there's just like no imperfections in the video. So like no little bits of noise or fuzziness, etc. It's just, the colours are all just solid. Zoom you in. I've just died, hang on. Look at the interface as well. It's like, it's crystal clear, totally stable. It's one of the best pictures I think I've ever seen out of an Amiga. Yeah, see that little line flicker in there? It's like Star Wars credits, isn't it? Do you know, I don't think I've ever watched this intro. Yeah, so it's like Blasteroids if you've never played this. Yeah, so it's interesting this is described as ECS. Maybe it needs a mega chip RAM. Can you see that flickering again? Yeah, that only seems to be appearing here on the Rev 4. I'll test on the Rev 6 just to make sure, but not really sure what the cause of that is at this stage. And testing on the Rev 6 A4000 there, no issue, no flicker. So, I don't know, there must be some bad connection or something on the Rev 4 there. It may even need a mod. So, the Rev 4 video stability's yeah, not affected by the cap that I've just added. I was trying to bring it in line with the Rev 6, so I added a cap there on the C4 line that comes out of Buster, goes to the video slot. Presumably it's not really the issue here because it could just glitch again there and again. I measured all the stuff to do with supply lines and things around the DAC and around all around the board. There's no supply issues here. That glitch, I don't know what it is. Yeah, so I think the T-base is the next thing. Let's add a cap onto that. That doesn't seem to have made any difference to that 47 picofarad cap on the C4 pin. Bear in mind, I couldn't find C920, which is 100 picofarad. I think that's what they put on the R4. I can't find it. I don't know where it is. It's really hard trying to find some of the caps on these boards. It's probably one of the ones where the label is underneath the component. So at this point I spent hours and hours comparing Rev 4 schematics to Rev 6. I thought I had found a missing pull-up on HSync, but what I'd actually found was another pin. I was measuring the wrong pin, and that actually happened a number of times. It was really difficult trying to trace the connections from Agnus all the way to the video slot there. And yeah, as you'll see when we look at the schematics a bit later on, there are some differences. You know, the Rev 4 doesn't buffer a number of signals. So you can see a screenshot of the PCB edge there. I had a look on both sides, both halves of the connector, and I was just like focusing on this side here. So you've got some suspect ones here: VC1, blank, VSync, HSync, BC-Sync. So these are the things that I've been scoping and looking at. So just testing Tom Mead's card again here. The problem is a lot less pronounced. In fact, I hardly ever see any kind of lines, artifacts or anything. Yeah, most stuff, even on the R4, just looks absolutely crystal clear perfect. No issues at all, so I don't know why it's like Syndicate was an issue. I did try the first Turrican and there were just like one or two little artifacts in sort of lines. I'm not even convinced it's a sync thing, to be honest. Because if there was a problem with HSync or VSync, I'd expect different behaviour. And look how crystal clear that is. Yeah, the interesting thing with this game is it's kind of like offset to the right, but that happens on RGB as well, which is weird. Right, the problem has been worked out, I think. You can still see we've got the noise here, yeah, occasional lines flickering across. Sometimes the impedance of the scope probe can actually help you, and that's what I figured. So I thought, well, let's just go back to looking at VC1. Now I did this before, but what I wasn't doing is playing around with the impedance and actually trying to scope it at the same time as looking. So if I scope it now, you can see there's hardly any lines, literally none. Pull the probe off, back again, put it back on, gone again. And if I change the impedance of the probe, I'll show this in a minute, times 1, which means it's not high impedance at the moment, it'll have more of an effect. Look at that, much worse. I'm like, yeah, bingo, that's it, take it away, picture back, but it's obviously the lines are there. Now the amazing thing is I have spent hours and hours and hours, like over the space of the last week or probably 2. I mean, I can't emphasise how many hours I've spent. So this is probing it on there, hang on, let's put it back on times 10, because the scope is set for times 10. You've got to set the trigger, you've got to set the acquisition thing the same as well, you know, so yeah, looking at that, can you see anything wrong with it? This is the thing. You could try a capture one shot or something, put it in one shot mode, and then you could, you know, zoom in a little bit and have a look. look, see what you're getting. But it kind of just looks alright, doesn't it? This is the thing. But something is definitely going on with that line. Bear in mind, we're now adding or altering the signal with impedance because of the probe, and this is the thing. If I look at the screen, it looks alright. So how would you, this is the thing, how would you know, the only thing you could do is have a higher impedance probe, times 50 or some, or times 100, because then you would be able to see maybe some ringing or something. Maybe there is a bit actually there on that. Yeah, there's something going on the top edge here, just every now and again it kind of looks like it's going up a little bit. It's just move. Hang on. I always forget how to do this. Yeah, you're getting like a little peak occasionally going up and down here. But you know what, it looks alright. I would have no clues looking at that as things stand as to what the cause of the problem might be. I don't know, you could hang on. Scroll around like that, see if you can see anything unusual. I mean, you can see because of the sample window there, look how approximated that is. This is the thing when you do a zoomed out, you know, a capture of a large amount of data as it did, you lose the shape to it. It looks a bit weird on the bottom down here as well, but anyway, trust me, that is the problem. So I now need to buffer that signal, and that should solve the issue. And it's on times 10 still, so I don't need to adjust that. And I'll just wait, and then I'll get back on. So I'll just get ready. So I'll wait till you've seen a few. So you can see lots of lines jittering around there. Now scoping it, holding the probe on there. See how much better it is. So little test clips like this can be really useful. You can see I've just got a 4K7 for 10K, it was a bit high, let's just go 4K7 and we'll pull it down and see if that reduces any reflection. And I think actually that's the answer, because if you watch this noisy area here as it flickers, it's really hard to for me to see what's going on at the same time as trying to connect this clip. Right, so hopefully you can see that. It's quite hard for me to see whether it's in the right place or not. So I'm on that pin, hang on, holding it on, hang on, right, I'm on that pin, holding it on. See there's no flickering, none, zero, zip, nada. And 3, 2, 1, I'll pull it away, ready, 3, 2, 1, oh hang on. We actually lost the signal for a minute there, but there you go, you can see it's back again, jittering all over the place. Yeah, so we've got a ground there. It's the second pin on this top connector. So I can just simply, well, just use the cutters to do this. Just bend it around sort of that point. And we'll solder it on. But before I do that, I'm going to straighten it back out again now. Right, so strangely that didn't work. You can see I relocated the ground here, because when we tested, I was testing from a clip here on a slightly extended length of cable. Just the same. It's maybe marginally better. So yeah, the solution is you just buy yourself one of these. They're about, I don't know, £6 or £7 on eBay, maybe a bit cheaper. You could buy in bulk and just solder the point there. Maybe at this angle, sort of solder it on, and then just like, I don't know, coil the cable up inside your case. I'm kidding, by the way, you know, I am not being serious here. A capacitor. So I've just tested with the capacitor, the same thing works, even though the resistor's there. We're creating an RC delay by doing that. But if I remove this resistor now and just solder a 47 picofarad cap on that pin, maybe the problem will go away. Because the thing is, when we had those clips, you know, the croc clips, well, not really croc clips, these test clips with a resistor on, it's quite a long length and you're adding some capacitance. So you may think you're adding resistance because you've got resistor there, but actually it's the capacitance that was solving it. And there is a resistor in series that comes from, you know, because that clock originates from Agnus. It comes out, goes to Gary as well, I think, but on its way here, it passes through a 47 ohm resistor. So you've got a bit of a voltage divider going on here, it obviously worked when we had the clips on, but not when it's soldered in place like that. That tells me that it isn't about the voltage level or reflection as such. I think, well, this will be reducing any reflection, but obviously I don't think that's the issue. I think it just needs that cap on there, maybe to add a bit of filtering or something, or maybe just extend the edge a little bit. That seems to be what it is. Yeah, actually that does seem to have fixed it. So maybe the capacitance is not absolutely perfect, but you know what, that's a million times better than it was. There's no flickering, weird scanline stuff going on here at all. I'm going to call that one a success, I think. What you really want is, well, you need to be able to capture that signal. Yeah, you need to capture it, zoom through it, and it needs to be high detail, you know, high, what's the word, resolution capture, you know, so you can actually see all the individual points and things sufficiently. The depth, I think, the capture, you know, the memory of the scope is probably nowhere near sufficient to capture something like that. I'm not, someone in the comments below is probably going to correct me and say, no, I could do that on that scope easily. Because then if you could work out where the anomaly is occurring, you know, because what's happening is every now and again there's just like a little blip on that line, on that clock line, like an extra, you know, a slightly higher peak or just something, some reflection or something on one of the edges. And if you can't see it, you don't know whether you've solved it completely. Well, I think we have. We might have just reduced it significantly, but by changing the capacitance there, we could reduce it further. And the point I'm trying to make is, it's about frequency and stuff, isn't it? If you can work out exactly maybe what frequency it's occurring on, you might be able to deal with it. But then again, it's going to be irregular. If it's like a capacitive thing, you know, a parasitic capacitance maybe, it might have a regular frequency to it. And then sizing up a capacitor against something like that can be quite difficult. Anyway, I'm going to call that a success. It's rock solid. Woohoo! I can finally wrap up this video, I think. So please, let's just have a scroll around, make sure there's no weird anomalies as we go further up. It's interesting, isn't it, how the issue was appearing at different places on the screen here, depending on where we were. Which kind of leads you to think it could be about current dips, or, you know, just usage on certain signals that run nearby those connections. It could even be some noise that's been generated inside Agnus as different things are going on within the chip. I don't know, it could be that's what we might be doing here, filtering a bit of noise out. But then again, it's kind of buffered. It comes, mind you, it's not buffered, is it? On this one, it just comes straight out of the 47 ohm resistor. And this is the thing. So another better solution, someone might be screaming at the cameras, you know, with this better solution. The better solution would be to just buffer that signal. Yeah, do what we did with the V-blank, you know, the V-Sync signal, and add a little Schmidt or something. But we've got away without that. And you know what? Adding a capacitor on is so much easier than trying to buffer with a 7.4 series. So I did swap out a couple of main caps, one near Denise, one near Agnus. So this is the 47 microfarad. I think that was near Denise actually. Yeah, so it's within spec, and I'll show you again. It goes ding ding, I think, or ding. Yeah, that means that's okay. So yeah, that's what I always say really, that there's no reason to rush in and replace every single cap in something like an A2000. But I would do the largest ones, you know, that's what I did. I did all the main ones and swapped with an FR series. And the two I fitted on there were FRs as well, FR series. Yeah, 4.7 that one, again, it's in spec. But those can go into the bag of a million capacitors here, of which 99.9% of them are okay. Yeah, my post-apocalypse storage. So yeah, just trying a few different games here. They've got bright colours and lots of black area and stuff, a bit like Syndicate really. And I've not seen a single issue anywhere. It looks incredible, even on the R4000. Yeah, so I think final test now, I'll just connect it back up with the RTG card, because that was where I first noticed that weird issue. I'll just see if the two play ball together. I can't throw upwards, my joystick's not working in the up direction. I'm gonna have to do an own goal, aren't I? So the AGA Multifix and the RTG connected it together. There's an added benefit of that mod. It's actually made this nice and sharp again. It looks perfect as it would be if you were taking video directly from the card without it going through to the RTG and back again. So yeah, that's kind of unexpected. As an unexpected bonus for me. So I'll try and remember how to do this now. Let's see if we can test one of the RTG modes. But it looks crystal clear. Let's do 1024x768 again. Hey, fantastic. Thought I'd just show you a bit of rough and tumble. The colours are really good on this, exceptional, in fact. And if I zoom you in a bit, you'll be able to see how stable it is. And look at our main character there. Sweet. Yeah, looking at the schematics here, you can see some of these signals here go to the video slot. So we've got like VC1, VC3, and a number of other signals. So VC1 was the one that fixed this. And if you follow it, this is the Rev 6. It comes from a resistor there, which is 47 ohms. But it comes through this NOT, you know, an inverter here, this buffer, 74F04, and goes to Agnus and to Gary. And there's a cap, on the two main clock lines there, CCK and XCCK, is it, or something, or CCKQ. But anyway, those ultimately, you know, do get buffered on the Rev 6. They don't get buffered on the Rev 4. So depending on what you've got in that video slot, there might be a benefit in putting a capacitor on VC3 as well. But you could just replicate the buffer here. I mean, it's already going through a 47 ohm resistor, but yeah, you could buffer it. And actually, now I think about it, when I actually checked this, I think it was buffered. I think these two signals are buffered. So, I don't know, I could be talking rubbish here. I'd need to go back and check VC1. So quite why it needs that cap, I'm not entirely sure, but that nevertheless seems to fix the problem on a Rev 4. And there you go, you can see the mod. So it goes on the top slot nearest the top of the board there. And it's the second pin. 47 picofarad cap to the other side going to the nearest ground. So hopefully that's focusing. A quick look at the board at the end here. You can see it's pretty good. The hassle connections here, you know, HASL, hot air surface leveling, I think it stands for, hot air surface leveling. Yeah, I use the braid on these and just to rule it out and you know, flatten them further. But yeah, gold plating is what you want on here. And Sparks himself admitted this, that yeah, it's something he's become aware of with these boards. That if you have the option, always go with gold edging there. So yeah, no real issues with this. It did have quite a lot of bits of things bodged on it at various points. There's a few sticky fingerprints still on there, I think. It's been through the ultrasonic about 4 times. This has had copper tape on and off, and you saw some of that, I think, within the video here. And I did solder to one of the wires here to join the grounds up and stuff to that copper tape, but ultimately it didn't need any copper tape. So at the end of this video here, we've resolved a number of issues. In part 1, we created the that VSync, you know, tick fix, and then in this video we sorted the buffering out on the video slot there, on the RGB lines for the Amiga 2000, and I did that same mod. I needed to do that same mod on the Rev 4, so yeah, there may be a separate video just wrapping up that mod as a thing on its own. But then we also had the VC1 issue, you know, having to add the capacitor on the underneath of the 2000 there. So the only outstanding issues, I'll stick the firmware up there. That's the one I use for this, which I believe is the latest one. Yeah, the switch to go, I think it's that bottom one, isn't it? To go, you know, blacker than black. You saw when we tested it on the 4000, it didn't work. It's like, you know, 2/3 of the screen went dark or something. It did something strange, so not quite sure why that is. It works perfectly on the 2000 for that reason. I'm just going to stick it in the 2000 for the moment. But conversely, the scan line alignment thing with Interlaced, you know, the even lines, if you think about it, seem straight, you know, perfectly aligned with each other, and the other lines are 1 pixel across, so you get that kind of like an alias kind of look to it. So it, you know, looks a wee bit blurry on my LCD display, but that didn't happen on the 4000. I don't really understand what that's all about. So yeah, firmware related, I think there's a little glitch in there. And corrections from part 1, this does use VSync. So yeah, I mean, I checked VSync and HSync when I was trying to resolve the issues with Syndicate there. And I didn't really talk about it, but I'll talk about it more in the video for Tom Meads' card, because that's an older Scandoubler. yeah, you've got 2 lots of RAM here. One of them is a frame buffer RAM, captures a whole frame. So those are quite large. I know they're smaller, but they actually hold more data, I think. Whereas these are line buffers, they just capture a single scan line at a time. And as I sort of mentioned, I think, you know, we just had at one point, I think it was the bottom ones of each of these, you know, each of these pairs, and it worked fine. At some point I tested interlace mode that way, and you had a scan line effect. So my point there is you could have like scan line mode by just not having all of the RAM. And it's nice, I think, the way this is configured is, you know, you've got like red, green and blue. I forget which order these are in, but when we come to look at Tom Meads' card, it's a bit different. It's like some of the colours are going through each of the chips, so when one chip fails you get weird colours and you're like, I'm not really sure which chip it is. You have to do a bit of chip swapping and try and work it out. Yeah, we didn't cover anything with this jumper here. I'm not sure what that is. Comments down below if you know more about that. And obviously I've done nothing with the USB thing here. I should install a pin header there, and then I forget some of the board that allows a USB you know, connection to break out from the main board. I can plug it on here, and then I've got USB easily accessed on the back of the system there. So a massive thanks to Sparks UK. Had some help from Liv2 as well in part 1, Matt Harlem, and thanks to all of my patrons in Discord that got together and arranged for this as a birthday present. I love it. I've enjoyed working on it. It's taken a huge amount of time, but I have thoroughly enjoyed working my way through the issues on this. So I guess the only thing we're waiting for maybe is a future firmware update that might fix the scanline thing and the blacker than black switch for the 4000. Anyway, I do hope you found the video interesting. If you'd like to support the channel, please see the Ko-fi and Patreon links down below. I'll catch you in the next video.